I can write a full RAG application in minutes, 20 lines of Python code, and it's working. It's a great proof of concept. Now, I want to build this application using production-grade services. OPEA is here to help. OPEA provides microservices that you can use to construct full GenAI applications. These microservices can run on various clouds platforms like AWS, Azure, Google, and more, and of course, on-prem on your machine. They can run on CPUs, GPUs, or AI accelerator. They all run standalone containers, and they are composable. Let me show you an example. I'll build a typical RAG application using LangGraph. The power of libraries like LangGraph and LangChain and others is the ease of use and how fast you can build a full pipeline. But then I will replace some of the pipe stages with OPEA microservices. The scenario I had in mind was, okay, I start with a simple Python LangChain application. Then, when I discover that my inference costs too much or cannot handle so many users so fast, I can replace each of the pipe stages with an OPEA microservice and run it in the cloud, clouds, or anywhere. Start at the Intel Tiber AI Cloud, catalog, hardware. I'll take a CPU, for example. I'll take a Xeon 6 chain, powerful machine. Give it a name. Make sure one click is on. One click, and we are in. I'll take this example with small modifications from the LangChain OPEA project. I'll leave you the link below. Right here, under samples, QA streaming. So this is a standalone RAG application. Needs some installation, Hugging Face token. And here is the first stage in the chain. Our LLM is the Intel Neural Chat with all the parameters running on the CPU. Embedding, you can see the model. Vector store, will be retrieving information from this document. And here is the loader and the text splitter. And here we start to build the application. It's a graph, so you need to define the state, retrieve and generate, build the graph, and just run. Next stage is to create microservices using OPEA. I'll open the compose file. You can see here two microservices, the embedding microservice and the inference one. You just need to take the right container for the right device. This is the port, the model is placed here. I'll be running it on the same machine, but it can run anywhere. Proxy if you need, and that is all. Docker compose app, everything is brought, built, and executed. And we have two services, text generation and text embedding, running. And now you can see on the left the original pipeline we just ran, and on the right the new pipeline using OPEA. Still need to install stuff, and here is where we called the LLM. Now we'll call an IP address, here local, to get the same result. This is a document to read, this is an embedding model, and this is a corresponding OPEA embedding microservice that will replace it. And I will just run the new application stage by stage, and I got the answer. This will print it a little bit nicer, working. I have just built a full RAG pipeline using standard libraries. It could be LangGraph, LangChain, or others, then replaced two of the critical stages in the graph or the chain with OPEA microservices. So now I got the ease of use, fast start, abstraction level of these Python libraries, and the embedding and the inference will run in the secure, scalable machines that the cloud can provide me using OPEA services. Try it out. Subscribe. Thank you.